If it's okay.
All right, section 3.1. Got it. Didn't do that. What is it? 0307?
0307.
0307. Okay. What we want to hit today, graph some quadratic functions. Not a ton, just a little bit. But more number 3. Solving problems modeled by quadratic functions. Okay. The first thing here, the book, our book, your book, calls this the standard form of a quadratic function. Other books will talk about f of x equals ax squared plus bx plus c being the standard form. So you got to just double check when it says write it in standard form, what is it asking for. A lot of times I'll call this vertex form because I think it's a little more obvious. If it's in this form, you are going to know what the vertex is. You're going to know what the axis of symmetry is. What's the axis of symmetry? Do you just remember that just from past, what that represents or what that is? Axis of symmetry is the line that cuts it in half. Okay, right down the middle. The vertical line for that. And it goes through the H. Now you got that function there, that equation. Let's use what we know about shifting. And that's kind of using that same idea. Well, what does the plus 4 do? It shifts it which way? Left 4, what's the minus 3 do? Down 3. So that means this vertex will now be at -4, -3. Okay? So the vertex will be at -4, -3. The axis of symmetry. Now, thanks, Christian. You know where your group is? Huh? They just left you?
Yep.
Oh, they're playing down the field. Did you ask her? Library? Okay. And so remember, since that's a +4, this is the one where it's the opposite, but you gotta be careful here. That -3 is gonna be the same. All right, axis of symmetry. What's it gonna be in this case? So the axis of symmetry is going to be x equals -4. It's always the count x equals because that's a vertical line. It's not part of the graph. So I'm going to draw it in as a dotted line. Basically, any point on the right, there's a mirror point on the left. Okay, any point on the left, there's a mirror point on the right. So we can just plot a couple points and then get their mirror points just to finish this parabola. So plug in, I don't know, -3. All right, let's see what we get back when you plug in -3. Go ahead. What do we get? -3 becomes 1 squared, -1, is that right? -3, -1. So that is a point here. That means there's a mirror point on the other side. That acts as symmetry. So if I plug in -5, I got to get back -1. I'll plug in -2. If I plug in -2, I get -2 plus 4, which is 2. Square that is 4. 8 minus 3, 5. So I get -2, 5. That means I get a mirror point here. Graph that. Okay. So key things here. Axis of symmetry. Cuts it in half. Vertex. That's your highest point or your lowest point. It's the turning point where it goes from increasing to decreasing or decreasing to increasing. All right. Very important for how to determine those. All right. All I'm asking for is find the vertex. Well, you should be able to look at that and tell me what the vertex is. Okay. Tony, what's my vertex going to be for number 1 now?
3, 8.
3, 8. Boom. That's it. Does this equation open, or does this graph open up or down? Okay, and from just by looking at that, can we tell? Jacob, do you know if it opens up or down?
It opens down.
Okay, because this -2, when you're done, if you would put it in this standard form, you'd have a -2x squared. So this is what I know. I know right there, that point is 3, 8. And that's going to get cut in half by the axis of symmetry. Okay, so I know a lot of information. Number 2, what's the vertex looking at that? All right, is it obvious? No, it is not obvious. That's why that vertex form is kind of nice, because all I got to do is look at it and say, hey, I know where the vertex is. Well, to find the vertex, I'm going to put it in that form. So I got to make it a quantity squared. All right, here's how we're going to do that. Is we're going to take your x squared plus 4x, and we're going to complete the square, because we got to get a quantity squared. Okay? So this is going to be f of x equals, do this, x squared plus 4x, and then put a spot blank. We're going to fill that in. Well, I still have this -5. Bless you. And if I want to keep this f of x, so we're going to do something a little bit different than we did with circles. I'm going to put both pieces on the same side. I'll show you what we're going to do here in a second. So if I add something here, I'm going to have to counter it as well. All right, if I complete the square, well, what's half of 4? That is 2 squared, we get 4. So this number is going to be a 4. All right, here's what we have to do. Is got to make sure that this is still equivalent to the original one. So if I add 4, I got to counter it by basically subtracting 4. So I'm going to put a plus a -4 right there. We haven't changed it, have we? Because it's still, I put in a 4, but I countered it with a -4. I'm just altering his form to get what I want. So f of x equals, now factor that trinomial, and it's going to factor into x plus 2 squared, and then you just get -9. All right. Now do we know the vertex? Yeah. We got it in that form. I just pull the vertex out. It is -2, -9. So my vertex is -2, -9. So if it's in ax squared plus bx plus c form, I'm going to complete the square. I'm going to create a quantity squared. That'll give me my x coordinate of the vertex. All right, the third one, 3x squared plus 12x minus 7. All right, this is a little bit harder. Why? That 3, you cannot complete the square if you have a coefficient in front. Well, what did we do before? I think it was with circles. What did we do? How do we get rid of that 3?
Divide.
We divided everything by 3, but that's going to cause a problem because I'd have to divide this by 3. And then that's going to mess things up. So here's what you can do is you can basically factor it out. So take the first 2 terms. Don't worry about the constant at all. But you got to work with the first 2 terms. So you're going to have g of x equals 3 parentheses x squared plus 4x, because I factored a 3 out. We're going to add in a spot to complete the square. I still got my -7, and I'm going to have to add in a constant to counter whatever I put in here. All right, at this point, you make sure you understand it's still equivalent to what's above there, right? Still, if I distributed 3, I'd get everything the same. All right, well, daggone it, this ends up being the same type of completing the square as the last one. What's half of 4? 2, square it, you get 4. All right, now watch here, be careful. You don't put a -4 over there because this 3 is affecting that 4. That 3 is multiplying the 4, so it's really, we're adding a total of 12. So to counter, we got to put in -12. Okay, So watch that, especially whether you're dealing with factoring. So now, g of x equals 3 quantity x plus 2 squared minus 19. Minus 19. Vertex. Vertex is -2, -19. G of x equals 3x squared plus 12x minus 7. Hey, there's another way to get the vertex without doing that. Do you remember from, I don't know, algebra 2, I can't remember if you did it there. It was way a little bit further back. Okay, Hess, don't remember? Anybody else? All right. Flip it over. No. Oh, shoot. I'm a problem ahead. Never mind. Back up. Back it up. All right, let's do this one here. Then we'll do that. Find the standard form. Now, when they say standard form, they're talking about the quantity squared. They're talking about the quantity squared of the quadratic function whose graph has a vertex of 1, -5, and passes through the point 3, 7. All right, what is the general standard form? Y equals A times x minus h squared plus k. Okay, that's our general form. What do we know out of those? Do I know h? H is 1. Do I know k? It's -5. So I know those. So I got y equals a times x minus 1 quantity squared minus 5. What don't I know? I don't know a. Not sure what it is at this point. But if they give us another point, that's probably going to have something to do with it. Take that point, plug it in. Okay, take this form right where you're at. Plug in 3, 7. 3 is going to go in for x. 7 is going to go in for y. And so it'll be 7 equals a times 3 minus 1 squared minus 5. All right, you can solve that because you're down to a single variable. 3 minus 1 is 2. 2 squared gives me 4. But write it as 4a. Okay, you don't write it as a4. Minus 5, add 5 to both sides. 12 equals 4a. Divide by 4a equals 3. Now, just according to the directions, just write the final answer down. Right? Y technically is a function, so we can write it f of x equals what? 3. X minus 1 squared minus 5. So if it's in this form, this standard form, I know what the vertex is. Okay, I know what the vertex is, but I have to convert it. As I started to say here, there is a way to find the vertex without completing the square. And that's on the back. If it's already in that ax squared plus bx plus c form, we can find the x coordinate of the vertex by that following equation. So h equals -b over 2a. H equals -b over 2a. For that. And if you remember, that gives us the equation for the axis of symmetry, and then we'll kind of finish it from there. But for this example here, now this is the same equation from the other side. We're going to talk about it here in a little bit different format, but we're going to have to find the vertex. It says find the maximum or minimum value of f of x, the highest or lowest. Well, is it going to have a maximum or is it going to be a minimum? Okay, as you take a look at that equation, or you're not sure. Okay, as you look, Peyton Rader, do you think it's a maximum? Do you think it's a minimum, or not sure?
Not sure.
Not sure. Cole Rose?
Not sure.
Not sure. Lane?
Not sure. Minimum,
Why?
because it's going upwards, so the origin or the Like the vertex would be at the bottom, so that would be the minimum.
All right, it's going to be a parabola, opens up. So now, does it make sense when you look at that? It's got to have a minimum. If it opened down, it would have a what? Maximum. The minimum or the maximum will occur at the vertex. So we got to find the vertex. So for part A, find the vertex. Well, let's assume we don't know what it is from the previous problem. And let's use what we just used right above that. How do I find the x coordinate of the vertex? You use that little formula, h equals negative b over 2a. You know, right?
Yep.
Okay. So I'm going to use h equals negative b over 2a, which would be negative 12, or let me put it as negative b over 2a. Remember, b is a number in front of the x, so negative 12 over 2 times 3. And what's that give me? That gives me negative 2. All right, what do we do to find the y value, though? Aaron? Plug it into the equation. Okay, so plug that into the equation. And so I got g of negative 2 is 3 times negative 2 squared plus 12 plus 12 times negative 2. And then what is it? Is it minus 7? Minus 7. So g of negative 2. Negative 2 squared is 4. 3 times 4 is 12. Minus 24 is negative 12. Minus 7 looks like negative 19. So right here's what I got. It opens up. My vertex is a negative 2, negative 19. So I got to answer the question. What's the answer to the question? What is the minimum value? So don't just leave me the vertex and I hope I assume you know what it is. The minimum value is negative 19. The minimum is negative 19. Range of f of x. All right. Madison, you know what it is? Not sure. Okay, take a look at it. Everybody take a look at it. Cooper, you know what it is?
Infinity?
No. Shh. Nathan.
Bracket negative 19, comma infinity.
Bracket negative 19 to infinity. All right, now let's make sure we understand. Well, you really shouldn't have to do any work from here. We found the vertex, right? We know it opens up. So what y values does it have to hit? Well, the lowest y value is negative 19. It's going to hit everything up above, right? Okay. So that's how you can find the range from the vertex. So you shouldn't have to do like any additional work. You shouldn't even have to graph it, okay? But once you know that figure, you're okay. All right, now the good ones. All right, read through that. Get the art teacher. For $20 per student, she can enroll 40 students in her pottery class. However, for each decrease of $2 in the price, she can expect 10 more students. What price will maximize her revenue from the class? There's a couple of different ways you can do this. One is brute force, which means you just start figuring out each scenario and then figuring out which is the best. And the other one is using an equation. Sometimes brute force will miss cases that aren't obvious. Then that's where you need the equation. Right now, how much money? What is her revenue without changing the price of the class? How do we figure out what is the revenue? Make sure we understand that part of it. Okay.
$800, 20 times 40.
20 times 40. 20 times 40 because it's $20 times 40, which is 800. All right, what happens if she drops her price $2? What's going to happen? What's going to happen to the number of students? It's going to go to what? It's going to go to 50, right? So I drop the price from 20 to 18. The number of students goes up from 40 to what? 50. Is that better or worse than 800? Yeah, it's better. What does it give us? What's 18 times 50? It's 900. So at this point, it would be in her best interest, right, to drop the price $2. I want to get 10 more students. I want to make $100 more. All right, let's come up with a function to model this. Okay, so how can I come up with a function to model the changes in the price and the number of students? Okay, so first of all, we're looking for revenue. So I'm going to call it R of X, and it's going to be price times students. Price times students. Well, we know right now it's 20 times 40, but it's going to change. So how do we include that variance? Okay, we got to throw a variable in there. You got to think, how's that going to get handled? All right, think about that. How can I create a function? And you keep it just in terms of price times student. How's that price going to change each time? And how the number of students going to change each time? All right. Any ideas, Nathan?
Not right now.
Not right now? Good answer. Good answer. All right, well, I'll tell you. How about if I tell you, I'm gonna write the price as 20 minus 2x. If I do that, what do you think I'm gonna put for the students? What do you think I'm gonna put for the students? Okay, 20 minus 2x. Sorry?
Would you just do 40 plus 10?
Not just 10, but
10x.
10x. All right, 40 plus 10x. So if x equals 1, what happens there? That gives me what? 18, right? And that gives me what? 50. If I drop it. So what does really x represent? Oh, Martin, that was like, whoo.
I checked over like 3 of my answers. I know.
That took
It's a
that
dangerous
took a
game.
long time. Man, that's over. We're gonna have to put the over under, change it to the next one. I had it at 19 minutes, and that was definitely more. All right, what does x represent? What does x represent in this case? Or how could we do that? Peyton?
Like how many times you want to decrease your price by $2?
There you go. Exactly. Number of times you drop the price. Okay, so it's not the number of students, it's not the price, it's the number of times we decrease the price. So x equals number of times the price is dropped. We want to maximize the revenue. We want the highest revenue. Well, if you look at this, if we FOIL this together, will we get an x squared? Yeah. Okay, so FOIL this together. So R of x equals, okay, what do I get? I get 800, 20 times 10 is plus 200x minus 80x minus 20x squared. I'm going to write it in standard form. And that's negative 20x squared plus 120x plus 800. Is it a quadratic function? Yeah, you got an x squared. Which way does it open, up or down? It opens down, so that means the vertex is the maximum, right? That represents the maximum revenue. We want to find, we need that. So we want to find the vertex. Find the vertex. All right, do that using h equals negative b over 2a. I would not want, I mean, you could, but I wouldn't want to do the completing the square. So you could, but like I said, I wouldn't want to. All right, figure out what that h is. That x coordinate, negative b over 2a.
Good one. H,
What you want to do? You want to take 3 for you.
Yeah.
That's what you want.
It doesn't count. Okay.
A little more to the.
All right, what do we get for h? We get negative 120 over 2 times negative 20, right? Which is 3. All right, and now what's the y coordinate of the vertex? Plug in 3. What'd you get?
980.
980. So r of 3, when I plug that in, I get 980. So my vertex is 3, comma 980. All right, I want you to carefully read that problem and then give me the answer to the problem. We have enough information there. Let's see if you can figure out the answer to the question they are asking. Let me word it that way. What is the answer to the question they are asking? Okay. All right, first of all, what is the question they are asking? All right, Mackenzie Ward.
What price will maximize her revenue from the class?
All right, what is that? Do you know the answer?
No.
No. All right, but you know the question, so you're halfway there. Kodaluka, do you know the answer?
Is it $14?
It is $14. Now, where'd that come from? It's not 980. I wouldn't want to charge $980 a person. But right here, we said the price was 20 minus 2x. The number of students was 40 plus 10x. So x is 3, right? So the price is equal to 20 minus 2x, which is going to be $14. Well, if it asks for the number of students, how many students is that? 70. What does the 980 represent? Profit. That's how much revenue you get. Okay, that's how much revenue. So you got to read that. All right, graph this on your calculator. Graph that on your calculator. Negative 20x squared plus 120x plus 800. Whoa. All right, Luke. Yep. All right. Do not hit Zoom fit. Figure out what the function will look like. See if you can get it on your screen. Now you can type it in as the product, or you can do the negative 20 x squared. It'll still be the same. So negative 20x squared plus 120x plus 800. All right, so this is probably what you see, right? You see nothing. So you gotta be smarter than your calculator. Okay. I want to see that whole graph. I want to see that. We said it's a parabola, it opens down, right? I want to see it. Well, one thing you can do is you can go to your table and say, all right, where's this thing going? The reason you can't see anything is when I plug in 0, what does it give me back? It gives me back 800. And what's the highest my y value goes right now? 10. So at 0, it's at 10, and it should be at 800. So you want to make your Y max at least bigger than that. And these are all positive numbers. Okay? So go to your window, change your window. Right now, I don't necessarily need to change negative 10 to 10. I don't mess with the X as if I can help it. It's usually the Y. Okay. Now, in Zoom Fit sometimes works. More often than not, it just gives you things you can't really read. So I'm not a big fan. And you need to be smart. Like you got to be smart in your calculator. You got to know how to change that window. So what's a Y max I could put in there? Aaron Hess. And it doesn't have to be the right answer. We might take 2 or 3 times. 850. All right, he says 850. So we're going to go 850. Now I like to change my scale, and I'm just going to go every 100 so it doesn't look like it's trying to go every 1. I'm going to hit graph. That looks better. Do I see the top of it though? No. And I might actually extend it just a little bit here on my window. I'm going to make it go to 15. If I change that, I'm going to make this go every 2. And I'm going to make this go to 1,000. And we'll hit graph. All right, there we go. We can see it. Now, what this represents. Okay. These are the number of price drops. Well, the price drops is probably going to be a whole number. You're not going to do 1.2 price drops, but in this scenario. But it gives you an idea. The Y value is the revenue. So you see up here, that is the maximum revenue. And then what starts happening is it goes down. The revenue goes down. Okay. So as you take a look at that, we want that highest point. We want that maximum. We want that vertex. So graphically, you can hit second, calculate maximum, and just be to the left of it. And then be to the right of it. And then now remember we talked about it says 3.000. Remember it's just what? It is 3. And our Y value is 980. So that is the most money she can generate under these circumstances is to drop her price to $14. She'll get 70 students. She'll make 980. Now, it may or may not be worth to have 30 extra students for the extra dollar. Who knows? But that's the case. All right, look at part B. Or no, the next one down. The next one down. Can you come up with a function to represent that scenario? Can you come up with a function to represent that scenario? Okay, so the farmer has 1,900 feet of fence with which to fence a rectangular plot of land. The plot lies along a river, okay, conveniently, so that only 3 sides need to be fenced. Estimate the largest area that can be fenced. So largest area, maximum area. Here's my river. Area equals length times width. All right, so area equals length times width. I got to use that to come up with a function. Now here's the deal. You have to be able to write one variable in terms of the other. Okay, length equals, I don't know, 2W or whatever. They're going to give you information to do that. All right, any ideas? Any ideas? Okay. 1,900 feet of fence is going to come into play. 1,900 feet of fence doesn't represent the area. What's it actually going to represent? Okay, what's it going to represent?
Perimeter.
Perimeter, right? Now, how many sides are on this perimeter, though? 3. It's only 3 sides. So I got 2 widths and a length, right? So 2 widths, 2W plus L has to equal 1,900, correct? Can you isolate one of those variables? Yeah, which one would be easiest to isolate? Isolate the L. So the length has to equal what? 1900 minus 2W. Well, take that and plug it in for the length over here. So the area has to equal 1900 minus 2W times W. Okay, length times width. All right, distribute your W. Area equals 1900W minus 2W squared. And I'm just going to write it in descending order. It's a quadratic equation. You have a W squared. It's going to open down because you have a negative in front of the 2. And so it means it's going to have a maximum. We want to find that maximum. Okay, we want to find the maximum. Graphing is an option, but you may not, there's going to be cases where you're not going to have your calculator on this chapter. So you got to, what would be our other option if we want to find the maximum? We got to find the vertex. So to find the vertex, I want to use h equals negative b over 2a. To find the x coordinate, or in this case, the w coordinate. So h equals negative b over 2a, which would be negative 1900 over 2 times negative 2. And what does that equal? 475? All right, from there, see if you can answer the question. You have enough information. See if you can put this all together to answer the question asked. Open it back up. That's a completion. Kayla, what's our answer?
No idea.
Oh, it's right on your calculator.
That's the actual answer?
Yeah, even though you don't know it.
451,250.
Okay. So now we've got all the work. We got to be able to arrive at the answer. 451,250. Where'd you get that from? Lane, any ideas?
Plugging 475 back into the equation.
Yeah, plug in 475 back into the equation. So area equals negative 2W squared plus 19W. So the area is going to be negative 2 times 475 squared plus 1900 times 475. And then that's where we get the 451,000. Also, you can think of it this way. That right there, that's our W, right? That's our width. So your width is 475. The length is over here. It's 1900 minus 2W. Well, what's 1900 minus 2W? $1,900 minus 2 times 475 is 950. Well, how do you find the area of rectangle? Length times width, right? So it's 475 times 950, which is the same thing. Okay, same thing. So you can plug it into the function. That's absolutely fine. You can say, all right, what's the width? What's the length? Okay, so that gives you the W where the maximum area should happen, 475. Okay, 475. All right. Whew. For 46 and 50, just find the vertex.